My next cool language feature has to do with properties. So let's take a look at a typical code snippet that sets up a property in C#. So this is a very simple class called person that contains a single private string field to hold the person's name. I also declare a public property for getting and setting the name. This is standard boilerplate C# code that you've probably typed a million times in your projects. And that brings me to the main problem. We need to type this fragment of code so many times that it's really too much work. Wouldn't it be much better if we can compress all of this code down to 4 lines? Well, with auto properties, this is actually possible. Check this out. This is the exact same code. The C# compiler will compile this source code and produce the exact same thing. A private field and a public property getter and setter. But now I have to type a lot less source code to achieve the same result. So there you go. An auto property is a property where you simply type get and set right after the property declaration. The C# compiler will then automatically create a private field and fill in the code for the getter and setter for you. So now you might be wondering, why use properties at all? Isn't it much simpler to use a field and make it public, like this? See, exactly the same number of source code lines. But now I don't need complicated compiler magic to automatically create getters and setters for me. Why would I need this feature? Well, there are important reasons to use properties over public fields. Let's say you start by introducing a public field in your class. Then, a couple of weeks later, you discover that you need to lazy load this field. So now you have to refactor the field into a property and put the lazy loading code in the getter. But now you've introduced a breaking change. The interface of your assembly has changed because what was once a field is now a property. Any code that calls your library will need to be recompiled. Another problem is that you'll need new code to reflect your assembly. Fields are accessible through reflection by using the getFields method, but for properties you'll need the getProperties method. So any code that uses reflection, like say serialization code, will need to be changed to take your refactoring into account. And if you're developing GUI code, you will discover that declarative data binding only works on properties and not on fields. If you start out with a field and later discover you need to data bind the field with a user interface control, then you will have to refactor your code to get it working. And finally, properties can be part of an interface, but fields cannot. So, for example, if you need to add a color property or a name property to an interface, then go right ahead. There's no need to manually set up get and set methods. You can simply add the property to the interface directly. I do this many times in my code, and it's a great feature. So, to sum up, properties are useful because you can later add lazy loading or range check code without recompiling client code. You can add lazy loading or range check code without changing reflection code. You can only data bind against properties. And properties can be part of interfaces. So now let me show you a cool thing you can do with auto properties. Let's say we want to set up an immutable object. Immutable objects are objects that you set up in the constructor, and after that they can never be changed. This is very useful in multi-threaded code, where more than one thread can safely access the object without having to worry that fields might unexpectedly change their value. So how would you manually set up an immutable object? Well, like this. So I made the private field read-only, which means it can only be set in the class constructor. I've removed the property setter and added a constructor to initialize the field. This class can only be initialized with the constructor, and once it's instantiated, you can only get the name through the property. Now I will simplify the code by using auto properties. Here we go. Much shorter. Note that I specify a public getter and a private setter. Yes, you can do that. You can use different visibilities for the getter and setter. A very cool feature. So now I initialize my property by calling the private setter in the constructor. And from then on, the outside world can only access the public getter and not modify the value. However, there are two problems with this code. The compiler creates a normal backing field and not a read-only field like we want. And the setter is accessible from the entire person class, so the class itself can change the value. So we do not get the multi-threading benefits. The field is not read-only, and the person class can call the setter at any time and change the field. A thread has no guarantee that another thread will not unexpectedly change the value of the name field. Microsoft realized that this is a problem, and so they introduced a very nice feature in C#6. Now you can simply do this. Do you notice the change? The private setter is gone. The compiler is smart enough to realize that a read-only property can be backed with a private read-only field. And to initialize the property, the compiler allows me to refer to the setter in the constructor. Again, the compiler is smart and it will automatically refactor my code to refer to the private read-only field instead. And this truly creates an immutable object, with a read-only backing field and absolutely no property setter in the class. This class can now be safely used by more than one thread, without needing any thread locking or synchronization. Okay, let me summarize what we have learned in this lecture. Auto properties are a feature where the C# compiler automatically creates the getter and setter code and the backing field declaration. You write auto properties by following the property declaration with get and set without specifying their implementation. Auto properties are useful because they allow future changes to getter and setter code without breaking the assembly interface or requiring changes to reflection code. You can also data bind to properties and put them in interfaces. You can leave out the setter to create an immutable class with a read-only backing field and no setter.